In this video, we're going to solve a simple exponential equation, which will allow us to play with some key properties of exponential functions. So we have here e to the 3x equals 3e to the x. And we're going to follow some just basic guidelines that are good for solving any kind of function. First, we're going to get one side equal to 0. So we'll get one side equal to 0. Then we'll factor the other side. Then we will set each factor equal to 0 and solve. Okay, so here's our equation. First, let's get everything to one side. So we'll rewrite this as e to the 3x minus 3e to the x equals 0. Okay, so that seems nice, but maybe not the most helpful thing I've seen. But we did get it equal to 0. So next we would like to factor this side. And we have to be a little bit careful how we factor. But we can factor using an interesting property of exponential functions. So if you have a to the power of bc, that's the same as saying a to the b to the power of c, or just as easily a to the c to the power of b. What that means is that I can rewrite this as e to the x, all of that cubed, minus 3e to the x. And what that shows me is that I can actually factor out an e to the x. So let's go ahead and do that. This is really e to the x times, we'll have e to the x squared minus 3 equals 0. And now we've done one step of our factoring. We can actually do one other step. And that step will use the fact that if we have a squared minus b squared, that's the same as a plus b times a minus b. But we don't necessarily have a, we have e to the x. Well, that's fine. We can treat this e to the x squared as, well, what some people will do is they'll put a little u in here and then kind of do some u substitution. But this is a calculus course. By the end of this course, u substitution will mean something very different. So I'm hesitant to use that. But what we're really seeing in general is that this kind of looks like a quadratic equation. So we can treat it like a quadratic equation. And in this case, this kind of quadratic equation, we would solve it by factoring it using this rule. So we can rewrite this as e to the x. So this is a squared minus b squared. Our a in this case is e to the x. And then b squared is 3. That means that b has to be square root of 3. So we're going to have e to the x plus square root of 3 and e to the x minus square root of 3. Okay, so we've actually completely factored this side. And now our last goal is to set each factor equal to 0 and solve. So what happens when we do that? Well, our first factor is e to the x. This will never equal 0 because e to the x is always positive. The same thing is going to be true of e to the x plus square root of 3 equals 0. This will also have no solution because square root of 3 is positive, e to the x is positive, so that's going to be some positive number. It will never equal 0. But have no fear, we do have at least one solution here. That's going to come from e to the x minus square root of 3 equals 0. So let's go ahead and move that over here. So we'll have e to the x minus square root of 3 equals 0. This kind of equation, what you'll want to do is you'll want to get e to the power of something, or something to the power of something on one side, and hopefully just a constant on the other. If it's any more complicated than that, then you'll need to use some fancy tricks, but in this case it's not. So we'll have e to the x, we'll move the square root of 3 to the other side. And then to undo e to the x, we just need to take the natural log of both sides. So we'll have natural log of e to the x equals natural log of square root of 3. And we could immediately simplify this as just x, but just to show you what exactly the natural log does, what it does is it takes exponents and moves them out front. So we'll have natural log of e to the x, that will turn into x times the natural log of e. And actually we can do something similar here. Square root of 3 is just 3 to the power of 1/2, so we can write that as 1/2 natural log of 3. And now we'll observe natural log of e just equals 1. So this is just saying that x equals 1/2 natural log of 3. And that is our final answer. So as some key takeaways, we had to factor this equation and we had to use some properties of exponents to do so. Once we factored it, we had to set each factor equal to 0, but since we had exponential functions, a lot of those actually had no solution. So, and that's due to the fact that e to the x is always positive. It never equals 0. But once we did get to a part where there was a solution, what we needed to do was have it so that we had e to the x on one side, square some constant on the other side, really just some exponential function equals some other, hopefully either constant or maybe another exponential function. We took the natural log to undo the exponentiation, and then we simplified to get our answer. And that's how we did that problem.